The Model 2 stands as the first true demonstration of Tesla's Compact Modular Line, a system that reshapes how a small, affordable electric vehicle can be engineered, built, and scaled. In this video, we're diving into the structure and logic behind this new CML approach to understand why it makes the Model 2 practical, durable, cost-effective, and built for global mass production. Before we begin, make sure you subscribe and turn on notifications so you never miss any of our upcoming technology deep dives. At the heart of the Model 2's development is the Tesla Compact Modular Line, a refined, purpose-built extension of the unboxed production process designed specifically for the company's next generation of compact EVs. Instead of relying on a familiar method of adding more robots, rearranging stations, or stretching factory floors further, the CML method redefines the entire flow of building a car. Where traditional automakers drag a vehicle through hundreds of consecutive steps along a long linear line, Tesla CML organizes production into multiple island-style modules where the main components of the vehicle are constructed simultaneously. Only at the end are these large functional modules combined into one finished vehicle. This transformation slashes production time, lowers cost, reduces factory footprint, and raises output dramatically, all while preserving the technology, strength, and identity expected from a Tesla. For decades, automakers welded hundreds of metal pieces together to form a body, painted it, then added wiring, seats, electronics, exterior parts, and finally tested it. Every stage had bottlenecks, and errors often appeared late. Tesla began dismantling this outdated method with the introduction of gigacasting, using enormous high-pressure machines to cast huge vehicle sections in a single shot and eliminating hundreds of tiny pieces and welds. The Compact Modular Line takes that philosophy far beyond simply simplifying parts. It changes the whole movement of the vehicle inside the factory. Instead of a long tunnel-like sequence, the factory becomes a cluster of specialized cells. A Model 2 is split into several major modules: the primary structural frame, the battery block, the drive system, and the interior assembly, along with submodules like glass and doors. The frame integrates front and rear gigacastings with a structural battery pack, forming a stiff, load-bearing base. For this new generation, Tesla uses lightweight aluminum-ion batteries. These support fast charging, increased durability, improved efficiency, and lower ownership cost, all while doubling as a structural element. The drive module, motor, inverter, gearbox, cooling comes together in a separate cell and benefits from being paired with a lighter pack, delivering stronger acceleration and better energy use. Meanwhile, the entire interior is assembled on its own frame, including the dashboard, wiring harness, HVAC, seats, and center console. Each of these modules is built inside its own cell, optimized for a narrow, repeatable task, making automation simpler and far more scalable. Because the vehicle is broken into large building blocks, the production environment is reorganized. Instead of a massive line stretching across the building, Tesla uses compact, specialized manufacturing islands. One cell produces castings and the main frame. Another assembles the battery modules. A different cell constructs the interior. Another builds the drive unit. Robots inside these cells repeat a tight loop of predictable tasks. This allows faster upgrades, simpler replication in new factories, and rapid adjustments whenever Tesla improves designs. At the end, everything comes together in one central assembly zone. Alignment pins, bolt points, and plug-and-play electrical connectors allow modules to slide into place with high precision. Instead of workers crawling inside a partially finished car to mount wiring or install seats, the modules arrive fully prepared. They're aligned, bolted, and plugged in within minutes. The megacasting stage marks the beginning of this entire flow. By shrinking what used to be over 100 stamped pieces and more than 1,000 welds into a single massive cast segment, Tesla eliminates enormous complexity. For the Model 2, these castings consolidate even more components than before, producing a lighter, stiffer frame and reducing mechanical build time that would normally require dozens of small steps. With casting cycles taking only a few minutes, Tesla gains a strong, consistent structural base for module installation. From there, each module undergoes extensive preparation and testing. Instead of discovering issues after the whole car is assembled, the CML system detects and eliminates problems at the module level. Three-dimensional laser checks, torque sensors, voltage tests, and insulation scans catch defects early with high accuracy. This minimizes errors traveling down the line and reduces rework dramatically. Once approved, the modules join the main assembly zone. Servo-guided conveyors adjust angles and positions with millimeter precision, allowing modules to drop into place as though the vehicle were built from large industrial-grade Lego parts. Each module connects through standardized mechanical and electrical interfaces, letting assembly time fall to a fraction of traditional methods. After assembly, the vehicle enters a comprehensive automated inspection lane. The diagnostics test the motor, inverter, battery management system, sensors, cameras, and stability controls. A dyno run checks energy behavior under load, while infrared imaging identifies any abnormal heat. High-pressure water tests ensure sealing. Because defects were already filtered at the module stage, the majority of Model 2s pass final checks quickly and cleanly. If something does fail at this stage, CML introduces a massive improvement: quick modular rework. Instead of disassembling half the vehicle, technicians or robots can remove an entire module, interior, drive unit, or another component, in one controlled action and replace it with a new one. This keeps the main assembly flow running uninterrupted. Supporting all of this is an intelligent load balancing system. Every module and frame carries digital tags and sensors that track movement, timing, equipment status, and error frequency. AI analyzes this live data and automatically redistributes workload, preventing bottlenecks and maintaining stable cycle times. All these engineering decisions deliver significant advantages to the Model 2. By reducing thousands of small parts to a small collection of large components, Tesla eliminates countless opportunities for misalignment and defects. Assembly becomes cleaner, faster, and more predictable. Build hours drop nearly in half, doubling output capability within the same factory footprint. Independent module cells minimize downtime and reduce maintenance costs. Early detection prevents full vehicle rework, meaning more consistent quality and fewer errors reaching customers. The result is a car that costs less to build, arrives with higher quality, and offers a more reliable ownership experience. Ultimately, the Compact Modular Line isn't just about making a cheaper car. It represents a reinvention of automotive manufacturing. By lowering complexity, boosting quality, and accelerating production speed, Tesla transforms the Model 2 from a bold concept into a globally scalable reality. If you enjoyed this breakdown, remember to like the video and stay tuned for more deep insights into the future of manufacturing cycle.